I acknowledge that we are hosting our beekeeping field day on the lands of the Wonnewara Nation. I also acknowledge the traditional custodians of the various lands on which you are joining us today and any Aboriginal or Torres Strait Islander participants. I pay my respects to elders past, present and emerging and celebrate the diversity of Aboriginal culture and connections to the lands and waters of New South Wales. My name's Bianca Jiggins. I work for the Department of Primary Industries at Tocal College in the Honeybee team.
Good morning everyone. My name's Darren Bailey. I'm the Director of the Tocal Agricultural Centre and also the Principal of Tocal College. It's my privilege to welcome you to the 2020 Tocal Beekeeping Field Day. It's wonderful to have you join us in this way. Obviously this year things are a little bit different, but of course, as always, we have a great lineup of speakers, a whole range of interesting topics, and I'm sure you're going to enjoy your time with us. So can I thank you for joining us this way? It's great to do a virtual field day in this year of COVID-19. I want to thank our long-term partners that make this long-term field day possible. So I'm thinking, of course, of the New South Wales APRIS Association and the New South Wales Amateur Beekeepers Association. We also this year have the support of the Ween Bee Foundation and the Hunter Valley Amateur Beekeepers as well. So really appreciate the support that we have. We're in this together and we're really looking forward to a great range of speakers, not just across New South Wales, but this year also internationally. Really great to also acknowledge that this morning I am standing on Wonnewara country. I know people are tuning in from other parts of the country, but I just want to acknowledge both elders past and present and offer a special welcome if any Aboriginal or Torres Strait Islander people are joining us for this field day. If anyone has a deep insight into the importance of country and connection with country, it's beekeepers. So it's really great to host this day. I trust that the time that you'll be spending with us, you'll get new ideas, you'll be thinking about your practices and also your enterprise. So once again, we're really proud to be hosting the Beekeepers Field Day. We're really pleased that even though with circumstances and restrictions in place, we can still offer this opportunity of getting together, sharing ideas and information and work together to make this industry great. We know how important it is, whether we're talking about honey production, pollination services, or the positive impacts for the environment generally. So once again, I'd like to welcome you and wish you all the very best for your day. Thank you for joining us.
Hi, I'm Kelly Lees, Education Officer, Honeybees.
I'm Bianca Jiggins, Student Administration Assistant.
Kevin Tracy, Beekeeping Traineeship Development Officer.
Welcome everyone to the 41st Annual Tocal Beekeepers Field Day.
Enjoy.
Hi, welcome to Tocal College Beekeeping Field Day. I'm Bianca Jiggins. I am the Student Admin Assistant at the college and I'm here to tell you about our beekeeping skills and our Beekeeping Certificate 3. All our training at the college is aligned with national accredited training for the Certificate 3 in beekeeping. Honeybee education team are passionate about sharing their knowledge to help people of all levels of beekeeping to improve their beekeeping skills and to better serve the industry with healthier hives and better quality honey and hive products. The Beekeeping Certificate 3 training is a combination of blended online and face-to-face delivery. To find out more about our beekeeper training in the Cert 3 and any of our short course skills training, you can go to our Tocal College Education website and you can apply online for all of our courses. Those skills training courses are Honeybee Biosecurity, Spring Management of Honeybee Colonies, Rear Queen Bees, Beginning in Bees and Native Bees. So have a look at our website and put your name down for a class today. Introducing our first talk for the day, Kelly Lees from our honey team here at Tocal College, talking about all types of hives, pros and cons.
Hi, I'm Kelly Lees, Education Officer Honeybees at Tocal College, and I'm here to talk to you today about different hive types and the pros and cons of each hive type. Before I get started, I wanted to talk to you very briefly about managing honeybees. It doesn't matter what hive type you use, the management of the bees is the same. So you do need to check for pests and diseases and manage the colony in the same way, regardless of which hive type you have. This hive that I have here is a 10-frame Langstroth hive. So Langstroth hives come in 8-frame and 10-frame. This is a 10-frame. They have a few basic parts. So they have a bottom board and a landing board where the bees go in and out. This box is called the brood box. Then we have a queen excluder, the honey super, which is where the bees store the honey, and the lid. So if we take off the lid, you can have a look inside. Basically inside you'll find wired and waxed frames. And this is the most common kind of hive type used by commercial beekeepers and a lot of recreational keepers as well. And you can use wax foundation or plastic foundation. So these are in the super. If we lift off the super, you'll see that this is the queen excluder. So for beginners, I recommend that you do use a queen excluder. The queen excluder is designed to keep the queen in the lower box in the brood box so that when you're inspecting your hive, you know where the queen is. So she can't fit through the mesh. In the lower box is where the brood is kept, and this is where the queen is. So the queen lays all of her eggs in the brood box, and we usually use wax foundation in the brood box. So when you're inspecting a hive, you're removing these frames and you're checking on both sides to look at the brood, which is the young bees, to make sure that there's no pests or diseases. You need to do a minimum of 2 brood inspections a year, and you need to look at a minimum of 3 frames when you do that brood inspection. In terms of pros and cons for this hive, they're made of timber, so they're very hard wearing and durable as long as you treat the timber beforehand. So a lot of beekeepers will dip them in what's called copper naphthenate to treat the timber and then paint them, or you can also hot wax dip them. So they'll last a long time. The flip side of that is they do tend to be heavy. So if you're a smaller person or not as strong, lifting the honey supers can be difficult. So this is a flow hive. A flow hive is a modified Langstroth hive. So basically they have the same components as a Langstroth hive. They have a bottom board, they have a brood box, which is where the queen and the brood live. They have a queen excluder, a super, and a lid. Now, the super is where they really differ from a Langstroth hive, and I'll talk about that in a moment. So I'm just going to lift this super off. So down in the brood box with the flow hive, if you buy a flow hive, they actually come with foundationless frames. So the frames don't have the wire and wax that we saw in the other hive. So I want to talk about the pros and cons of a flow hive in terms of the brood box and also the honey super. So for beginners, foundationless frames can be difficult. With wired and wax frames, the bees have a barrier, so they have to draw out this comb. But if you have a box full of foundationless frames, basically when you put the bees in, instead of going horizontally along the frame, they might go acrossways. So they might build the comb across all of the frames, making it difficult for you to remove those frames. So if you are going to get a flow hive, I recommend that when you first start out, you do use wired and wax frames instead of the foundationless frames. Up in the honey super is where things are really different with the flow hive. So one of the pros of a flow hive is that you can actually extract the honey without taking the frames out. Inside the flow super, they have these patented flow frames, which are made out of food grade plastic, and they have this zigzag pattern of honeycomb. And basically the bees fill that plastic in the same way that they would fill a wax foundation, and then they cap it like normal, putting wax over the top. Now the flow hive actually has a viewing window at the side where you can see what the bees are doing inside the hive. So when you take off this covering, you can actually see the bees working, and sometimes you'll see that that's been capped. Now one of the tricky things, one of the cons about this system is that these flow frames aren't really designed to come out. They're a very tight fit, And sometimes the bees will be working from the centre to the outside or the outside to the centre. And so when you see this as capped or uncapped, it's difficult to tell if the frames in the middle have been capped before you extract that honey. So it is really important that you do try to take one out to have a look before you extract it. In the rear of the hive is another access window where you can see the ends of the frames. So how they work is that you remove a little plug in the top of the frame and you remove a plug in the bottom, which is where you put the tube for the honey to run out. You then insert the key into the frame and you turn it. What turning it does is it moves the cells of the plastic frame apart from each other, and the honey runs to the bottom of the frame and runs out the bottom of the super. So in terms of extracting honey, it's much more simple. You don't need an extractor, and so you need less equipment. I will stress that in terms of managing the bees, it's very important that you look in your brood box just like you would with a standard Langstroth hive. After you've extracted the honey, you insert the key on the other side and turn it back, and this resets the cells ready for the bees to fill them again. And then you remove the key. So in terms of extracting, it's much simpler, making sure that you do inspect your bees as normal. And resetting it for the bees so that they can start again. So the other thing I just wanted to talk about with Flow Hive very briefly, which can be a con, is the concept of bee space. So bee space is where bees can walk back to back past each other in between two frames in a beehive. Now it's quite a specific measurement, and with your Langstroth hives you have that ability to space the frames to make sure that you are observing bee space. It's the space that they would naturally build in a natural hive. Now if you compare the space in a Langstroth hive with the space within a flow frame, it's much tighter, so bees actually can't walk back to back inside the flow super. So this means that they can have a tendency to feel crowded, and that means that they can have a tendency to swarm more frequently than a standard Langstroth hive because they run out of space quicker. So one of the ways that you can manage this is actually to run a Langstroth box with wired and wax frames on your flow hive so that they feel like they have enough space, so they don't have that swarming tendency. So this is a polystyrene hive. It is a Langstroth hive. So the only difference with this hive is the fact that it's made from high density polystyrene. Now it has the same basic layout as the timber Langstroth hive. It has a bottom board, it has a brood box, sometimes has a queen excluder, a super and a lid. So in terms of the management of the bees, it's identical to the Langstroth hive. You're still doing pest and disease inspections. Pros and cons of this hive: it's very light because it's made out of polystyrene, so in terms of weight reduction, that's a benefit. The other thing is that it's got high insulative value, so the transfer of heat and cold from inside to outside is very minimal. So if you live in a climate that's very cold or very hot, these are quite good because the bees don't have to work as hard heating or cooling. So inside they look basically the same. They have a lid, they have a honey super where you would have wired and waxed frames. Now the reason I said they sometimes have a queen excluder is that I've found that the fit for the queen excluders is one of the cons of this hive. So they're very tight fit. They're designed to fit right up against the two boxes, so between the brood box and the super. And they're okay when you first put them on, but once the bees have been in the hive for a little while and they've put propolis on that excluder, getting it to fit back in that position perfectly can be quite difficult. So because the boxes are designed to sit down on top of one another to minimise air gaps, that excluder sometimes won't go back on. So that is definitely a downside to these hives. The other downside is, from a commercial perspective, they do dent. Although commercial beekeepers do use them, they're just a little bit easier to damage than the timber hive. So you do have to take a bit more care in terms of lifting them and moving them around. But the insulative value, I think, perhaps outweighs that downside. Some people might think that a downside of these hives is that they're made from polystyrene. However, they have been using them in Europe for 40 plus years, so they have a longevity similar to the timber hives. They do need to be painted like the timber hives to preserve them in the UV light. However, at the end of their useful life, they can actually be powdered up and used in concrete foundations. Okay, this is a warre hive. Now, a warre hive is sometimes referred to as a form of natural beekeeping. And the reason they say that is because the bees build their own comb within the hive instead of drawing out wax foundation. So these hives don't use wax foundation. They're quite a different setup to a standard Langstroth hive, which we've looked at previously. So they have this very complicated gabled roof. Basically, this roof is designed for insulation. So you can see when I take it off, it's got a big solid area inside, and insulation is usually added inside that box to keep the bees warm. They then have a box on top which is smaller than the other boxes, called the quilt box, and they will put insulation in this as well to keep the bees warm. This lower box, it's just called a box. They don't call it a brood box or a super. Basically, with a warre hive, you have to start off with a swarm or a package of bees because of the size of the frame. So it's square rather than rectangular. And inside the box we have these foundationless three-sided frames. The idea is that the bees build comb in here in a natural arc rather than in a square shape designated by a person. So you catch your bees, you pop them in there, they build natural comb in those frames. When that box is completely full, with warre beekeeping, what we do is we lift up this box and we put another box down the bottom and add this box back on top. There is no queen excluder. The idea is that as the brood builds out, the queen, if it's spring and summer, the queen will move down into the lower box and lay brood in the bottom box. And then once the brood up here hatches, the bees will put honey in here. So there's a constant rotation where the boxes are lifted up and a box is added on the bottom. Honey is removed from the top. Now, this leads to one of the downsides of the warre hive, because when you're adding boxes, usually what's done is all the boxes are lifted up together. So you do need a hive lifter in order to lift all the boxes up to add a box on the bottom. One of the other cons for a beginner especially is the foundationless frame. Much like the foundationless frames in the flow hive, the bees may or may not choose to go in the direction of the frame. Sometimes they go crossways, making it difficult to remove frames. That means that you can't adequately do a pest and disease inspection because you can't remove the frames from the hive. So you do need a hive lifter. It can be difficult to get the bees to go in the right direction. The other thing is you do have to crush the comb when you extract honey. So you take the frames out and you cut the comb out and then you crush it in a press, or you can squeeze it by hand. So it's a very different way of managing bees. However, in terms of its inspecting for pests and diseases and managing the brood, it's identical to the other hives. So it is really important that you are doing consistent brood inspections to make sure that the bees are healthy. So in terms of the management of the bees, for beginners, as I mentioned, this hive type doesn't actually use an excluder. So the idea is that the brood moves up and down depending on the weather. And so that means that when you're doing your inspections, you are searching for your queen so that you don't accidentally take her home in the honey super, because she is free to move throughout the hive. You can add lots of boxes to a warre hive. So you're just lifting it up, adding one on the bottom. Sometimes you're taking one off the top, but you can have up to 5 or 6 boxes added to the top, and the bees just move through that hive, building comb and filling them with honey. So the last hive I'd like to talk about is a top bar hive, sometimes called an African top bar hive or a Kenyan top bar hive. So these are hives that are built at hip height, and basically they use a foundationless frame system much like the warre hives. So when you open up a top bar hive, they have a big lid, you open up that lid, and inside what you're greeted with is frames pressed tightly against one another. So there's no gaps between the frames. When you lift the frames out, the bees build V-shaped or round comb, depending on the way the top bar hive has been built. Now, In terms of pros and cons of a top bar hive, the great thing about them is they're really good for people with disabilities or with injuries or older people who have difficulty lifting or bending. Because they're built at hip height, there's no bending over the hive. You just open the lid and you're working it at a very comfortable height. In terms of cons, the top bar hive is limited in space to the length that it's been constructed. So if it's 1 metre long, the bees have 1 metre of space. If it's 2 metres long, the bees have 2 metres of space. So in terms of management, you do need to manage removing honey from the top bar hive because they can quickly run out of space, particularly in spring and summer when they're very, very busy. And so there's no area where you can add additional space to that hive. They generally will put the brood towards the front of the top bar hive and then fill the back with honey. In terms of another con is that they can do similar to the flow hive and the warre hive in that they may not go along the length of the frame, but rather go along the length of the hive, making it difficult to remove those top bars. So you do need to be on top of your management so that you are able to remove those frames to inspect them. Now there is a variation on the top bar hive, sometimes called a coffin hive. And basically this is a hive that is like a Langstroth hive. It uses wired and wax frames. It's the same dimensions as a Langstroth hive, but like a top bar hive, it's built on legs at hip height. Now these do have the capacity to have boxes added to them on one end going up. So it's a variation on a top bar hive that means you can manage space a bit more adequately. They do have the wired and wax frames, which means that inspecting is made easy because the bees will follow that frame. So in terms of choosing a hive, it really comes down to personal preference. It comes down to your particular circumstances and how you want to manage your bees. Most of the hives are managed in the same way, so it's really important that you remember that regardless of the type of hive you get, in terms of actually managing the colony for health and strength and pests and diseases, the management is the same. You must inspect your brood box or the brood nest of the hive to make sure that there aren't any diseases and that there aren't any pests and that you have a healthy laying queen. The main difference between all of these hive types is the way that you extract and manage your honey production. So with the Langstroth hive, with wired and waxed frames, you are using an extractor. You're decapping they're taking the wax off the surface and then spinning them in an extractor. So you do need additional equipment. In terms of your warre hive and your top bar hive, you are crushing the comb, so you do need a fruit press or some other method of squashing the honey out of the frames and then replacing those frames. With the flow hive, obviously you're extracting directly from the hive, so there's no need for additional equipment. Really, that is the main difference, is the way that you're managing the honey. In terms of managing the bees, they're all very much the same.
G'day, Mark Page, New South Wales DPI Bee Biosecurity Officer Surveillance. So today we're going to have a look into a hive, see what's going on, recognise different areas of the hive, different castes of bees. So our smoker, very important. Bit of smoke into the hive disguises those alarm pheromones so the bees are not as aggressive, not always perfect. Also said that they fear a fire's coming, that they'll gorge themselves with honey, and then they're concentrating on that and not concentrating on what you're doing. When we're working with bees, nice and gentle approach. They don't like the rough behaviour, and also that can damage comb areas and things like that, especially once we're in the brood box, and especially the queen. So just zip up here. Now the bees will generally bring in 4 things to the hive, so nectar, which they'll convert to honey, evaporate that off. So that's their carbohydrate. They'll also bring in pollen, water in the hotter parts of summer, and also resins, which they use as a propolis for antimicrobial, antibacterial. Also seals up cracks when we're near the winter time, things like that. So a little bit of smoke at the entrance. Doesn't need a lot. And then gently lift the lid. Bit of smoke under there. Don't need a lot of smoke if the bees are behaving. So our lid comes off. Now in this case here we've got the top box as a honey super. There is a queen excluder. Then the bottom box here is our brood box. So in a hive cover there, I'll just remove that. Place that aside. And we'll just have a look what's happening up here in the honey super. So we can see there, good to see frames covered with bees, healthy hive. Capped honey up the top here. So once they've evaporated that nectar off, down around the 20% or below, they'll cap it. And in here we can see the open cells that they're working on and filling with nectar. And once that's mature, they'll cap that. So again, even when we're working up the top, nice and gentle. This is the frame I put in 3 days ago. So we can see they've drawn that, storing nectar up in the top here. Now bees will only draw comb if there's something to put in it. So if you give them frames and they're not doing anything with it, what's happening outside, the conditions, what's flowering, is there a nectar flow? So they'll only draw comb if they've got brood to put in there, or pollen to store, or nectar as such. Okay, so we'll remove that honey super. A little bit more smoke. Not a lot of smoke. Now pushing down with your hive tool when you're near that excluder, so that the blade of our hive tool doesn't damage that excluder. If we open that up, that could allow our queen to access up into the top box, and then she would be up above the excluder then. Now having a look at the excluder just to make sure our queen's not on there. Now I just pop that down here. Some people will put it on top of the honey super. If the queen was there and I missed her, then the chance is she'll drop down into that honey super, and then again we've got a queen above the excluder. So general rule of thumb is second frame in. But even if there's a lot of burr comb, which this one doesn't have a lot, you can pick another one. But be very gentle with this first frame. We don't want to roll our queen in case she's on it. So we'll go gently. And the bees respect that gentleness too. Slowly lifting that frame allows the bees to move out of the way, which is most important. So a pretty good frame of brood there. A lot of drone cells up the top here. I'll zoom in a bit. Now I've got a frame holder here, so I can use that, clip onto the side of the box, and that'll hold the first couple of frames till I get a bit of room in the brood box there. So I'll just zoom in. A little bit more smoke. And then we'll go to that second frame. Again, everything gentle. It's not a bad frame of brood there. I might shake the bees off this one, so we can have a closer look. I'll just check for the queen. So when you're handling frames, just rest on your forefingers and using your thumb and your other fingers, just manipulating backwards and forward, rolling that frame, using the sunlight, just like that. So I don't see the queen there, so I'm just going to remove these bees and we can have a closer look at this frame. It's got some good drone brood, some good worker brood, and quite a bit of pollen stores there. Fair bit of light shake come off there. We can see the worker brood there, so that light shake you can see the honey droplets or nectar droplets there. We've got drone brood up the top here, the big fat ones, and through here we've got the pollen. We will come in and have a closer look at those frames. So when we're inspecting, especially for pest or disease, it's important that we remove the bees. We cannot see through bees well enough. So we've got a couple of bees chewing out here, one chewing out here, but our brood looks pretty good. Just pop that one aside, go the next one in. It's a little bit patchy, that one, but there's a lot of pollen stored up in there. A fair bit of new brood coming through. I haven't spotted the queen yet, but I can see larvae and eggs, so I'm happy that she's around there somewhere. We don't have to always see the queen, but we need to understand that whether she's there or not. So pop that one back in, we'll go the next one in. And we'll also have a look at a new frame I put in only a few days ago. So again, a fair bit of pollen stored around that frame. Can't see the queen. Plenty of drones in this hive, but again I can see plenty of larvae coming through, plenty of pollen stored in there, so quite full of pollen. A good beginning to the season. So everything nice and gentle. And that's a pretty well full of pollen, that one. And there's our queen, just here. And she's just laid an egg there. You can see her wandering through. So I might zoom in and we'll have a closer look at that frame. So I'll just remove one of these, so a good idea to get some new frames into your brood box when conditions are good. So those ones have only been in a couple of days, so they're starting to draw them out, as you can see. Three drones there, a quite big bee, and again drawing out. Okay, we'll have a closer look at that frame with the queen on it, and also that frame I shook some bees off. So we can see the queen wandering through there. Long slender abdomen, more of a shiny patch on the thorax, less hair on there. She's searching around looking for a cell to lay in. big fellas here, this patch of drones. Some more of a rounded and fluffy abdomen. And the other smaller casts there are worker bees. Look over here, we've got one doing the waggle dance, just got pollen bags on, letting them know where the pollen is. So a brood frame with these smaller, flatter cappings or worker bees. Up the top here is drone brood. If we look at this bee here, it's just a young bee that's not long hashed out, quite light and fluffy. We can also see quite a good bit of pollen stores up around the top there. Alright, so code of practice, mandatory to do your 2 brood inspections every season, beginning of the season, springtime, this time of year, nice day, 20 plus degrees. More field bees are out foraging then, so we've got less bees to contend with in the hive. And also on a cooler day there's chances of chilling brood and things like that, upsetting their brood temperature, which they like to keep it around that 34 degrees, similar to our body temperatures. So, and the other important part is, as you saw when we shook those bees off, and I'll show you another one, that to see our brood and check what's happening, we need to remove those bees. Code of practice, you can see that pollen up through there, says that we inspect minimum of 3 frames of brood. In my eyes, best practice would be to inspect all frames with brood. Picking up diseases such as AFB early is a key part of beekeeping, which not only helps yourself but also helps other beekeepers. Finding it early, the best thing we can do. So when you're removing bees from a frame, I'll use this one. So bringing it up, 2 forefingers under the end bars, the end of the top bar, and then bringing it up into the heel of your thumb. Give it quite a good pull up and jerk down. And that gets rid of them pretty quick. We can also use a bee brush and brush the bees off, but when they're like this with that nectar, it gets pretty sticky. Have a bucket of water, you can wash your brush, things like that. Good to have a bucket of water when you're in the summer months anyway, you're working with a smoker, just in case something goes wrong. So I'll put this one back together now. Shuffle everything over and make the room. And a good idea with that last frame that goes in is to, I'll just use a bit of smoke to move some of these bees away. Shake the bees off that last frame, that way make sure your queen's not there. Know where she is. When we go to put this last frame in, we're not going to roll a whole heap of bees and cause a problem. And again, nice and gentle. Back down in. Move our frame holder. A little bit more smoke, we can move those bees away. If we are beekeeping, it's like gardening, we will kill plants when gardening, we will squash bees when beekeeping. minimise it as much as you can. Honey super back on. In a hive cover. And lastly, our lid again. So, remember, write down our records of inspection. Part of the code of practice now is to keep records of your brood inspections. Keep records of any other little things you see there. Disease, remembering New South Wales DPI, your notifiable pest or disease I should say, is American foul brood, European foul brood, chalk brood and nosema. There you go. Thank you. I have a visitor here. Look at this. George the photobombing dog.
It's a real privilege for us to have Jamie Ellis present on worker bees today. You might think you know it all, but there's plenty to learn now. This is part one of Dr. Jamie Ellis' presentation on worker bees.
Hello, my name is Jamie Ellis, and I'm a professor at the University of Florida in the Entomology and Nematology Department. It's my pleasure to be speaking to you all the way from Florida about worker honeybee tasks. So before I do that, I just want to give you a little bit of an overview of the University of Florida. We have about 55,000 students at the University of Florida, and our Entomology and Nematology Department is the largest such department in the United States. There's about 70 professors in our department, and I'm one of those. And of course, my specialties with honeybees. Personally, I have been a beekeeper since the age of 12, so it's about 30 years now. I grew up in Georgia in the United States of America, and have really traveled all around the world studying honeybees, working with honeybees, speaking to beekeepers and bee clubs all over the place. So it's really my pleasure to be able to join you guys today during your conference. So given that I'm talking about the tasks of worker honeybees, I want to share with you what I hope that you learn by the time this talk is over. My focus is to help you be able to recognize the general order of tasks that worker bees perform relative to their age, as well as identify worker bee tasks that are independent of age. In other words, I want you to know what worker honeybees do and why they do it so that you can appreciate the marvel that is the worker honeybee. And anytime I start a talk about worker honeybees, I always start with this slide. And it's the most complicated slide that you're going to see in the whole presentation. But given that I'm speaking to beekeepers, I'm sure that you are all very familiar with this topic. As you all know, there are three types of bees in a honeybee colony. They are the queen, the drones, and the worker bees. Now, you know, if you look at this uppermost image here, a queen can lay an egg and she can control whether that egg is fertilized or if that egg remains unfertilized. And they can do this because when queens mate, they store the semen from the drones with which they mate in a special organ in their body. That organ is called the spermatheca. So while queen bees are laying eggs, they can elect to release semen and fertilize those eggs that are passing out of their bodies, or they can withhold semen and keep those eggs unfertilized as those eggs pass out of their body. Of course, all of you know that unfertilized eggs ultimately become drone honeybees or the male honeybees. So male honeybees have only mothers. They have no fathers. So that's a really interesting fact about drone honeybees. They're really an interesting bee in general. And if the queen elects to fertilize that egg, it becomes a female. And that's really the limit of the control that queens have. They can produce female offspring and they can produce male offspring, but that is it. The worker honeybees then will take that female offspring and either feed it a lot of high quality food, in which case it becomes a queen, or they feed it less low quality food, in which case it becomes a worker. So the way to think about queens and workers is queens are basically overfed workers, workers are underfed queens. Now, if I were with you face to face giving this presentation, there's an analogy that I like to use to explain what's happening here. And I want you to think about it just from a very practical standpoint. Queens have all the genes necessary to have been a worker. I mean, the workers could have made that female offspring a worker. Instead, they fed it a lot of royal jelly and it became a queen. Likewise, that same female, if they feed a little bit, becomes a worker. So workers have all the genes necessary to be a queen. So queens could have been workers, workers could have been queens. So you have a clear example of how it's not the genes that these bees have that make them queens or workers, because they both have the same genes. Rather, it's the expression of those genes. And the analogy that I always give is, imagine that you're sitting in an auditorium, right in the very center of that large auditorium. On the left, let's say you have 5 lights from the back of the room to the front of the room, and on the right, you have 5 lights from the back of the room to the front of the room. So basically on the right side, the first light, and on the left side, the first light are the same type of light, the same quality of light, can produce the same intensity of light, and lights 2 and 2 the same, and lights 3 and 3 all the way down to light 5. Now imagine again on both sides of the room that there is a switch for each light. So on the right side of the room, there's a switch that controls light 1, a switch that controls light 2, a switch that controls light 3, a switch that controls light 4, and one that controls light 5. And likewise, on the left side of the room, you get exactly the same thing, a switch for each of the lights. Now, imagine that I come into that room and ask you to leave that room, and you're gone for 5 minutes. And while you're gone, I go to the right side of the room and flip on switches 2 and 4, but leave off switches 1, 3, and 5. And then I go to the left side of the room and switch on switches 1, 3, and 5, but leave off 2 and 4. Exactly the opposite of what I did on the right. And I invite you back in, you return to the middle of that auditorium, and you look to the right and you look to the left, and you would say both halves of the room are lit differently, right? But the funny thing is about these halves of the room is I could have flipped those switches on and matched patterns exactly. I could have had both light switches 1 on. I could have had both sides light switches 3 on, and so forth, but I didn't. I did 2 and 4 on one side, 1, 3, and 5 on the other. Well, that, boys and girls, is exactly what happens with queens and workers. They both have the same lights. They both are otherwise capable of having the same lights on or off with the same intensity or lack thereof of each light. The difference is queens have certain lights switched on and other lights switched off, while worker bees have some lights switched off, but other lights switched on. Basically, it's not the genes that control the difference per se. It's the turning off and on of those genes that make queens and workers. And that's one of the reasons that female bees, to me, are among the most fascinating insects on planet Earth, female honeybees, that is. Because just by turning off and on switches, you get a queen bee that can live 2 years, whose most complicated behavior is to go out on a mating trip. But for the rest of her life, she only lays eggs. Whereas worker bees, they've got a huge suite of behaviors. They're capable of doing all kinds of things. But they could have been a queen. It's amazing to think about it. We call this epigenetics. The best way to teach it is, let's say again, you leave that room, that auditorium, and while you're gone, I flip on and off light switches on both sides of the room, and then I put a cover on top of those switches so that no one else can turn those on and off. They're either locked on or locked off. And epigenetics, the epi means there's something above the gene that controls the expression of the gene, just like there's a cover that controls the expression of that light switch. I've flipped the switch, I've put a cover on it, and now it can't be controlled. Well, epigenetics happens similarly in queens and workers. There's a switch on the gene, and it's either on or off, and then you get workers or queens from the same genes, from the same female egg. All right, that's the study of epigenetics. Epi means above, so things above the genes responsible for the expression of those genes. So we got this really complex reproduction system. You've got females coming from diploid eggs or fertilized eggs. You've got males coming from unfertilized eggs or haploid eggs. And so as a result, this sex determination system is called haplodiploid sex determinant. Males are haploid, females are diploid. This is as complicated as I'm going to get in this presentation. The reason, though, that I like to start with this slide is because I really want to hammer home how amazing queen and worker bees are, given that both could have been the other. Now, this is a talk about the suite of behaviors that worker bees exhibit, but I just as easily could be giving you a talk about what queen bees do and then amaze you with the fact that both came from the same type of egg. So let's look at this a little further. When a queen lays an egg, about 3 days later, a female offspring will come out of that egg if that egg is indeed fertilized. So we get what we call larvae, right? So honeybees undergo complete metamorphosis. So you have eggs, larvae, pupae, and adults. And in this stage, you have the larval stage. They lie in the back of their cell in the shape of the letter C. Some beekeepers here call them C-shaped larvae. Other people call these larvae milk brood because they're sitting in a pool of brood food and it looks milky in appearance. So when we say C-shaped larvae or milk brood, we're talking about the youngest of larvae that honeybees undergo. From there, we get pre-pupae. That's when the larvae have finished eating. The bees will cap over their cells and those larvae will stand up, which is what you see in this image in the bottom right. So that technically is a larval stage, but it's the larval stage immediately before the pupal stage. So we call it the pre-pupal stage. They spend a couple of days as pre-pupae and then molt or shed their skin and become pupae. So you can see in the top of that bottom left image, you can see the youngest of pupae. It's still white. And as you go down that image, you see darkening pupae, darkening pupa. And at the very bottom, you get an adult bee that, if you're a worker, will emerge from its cell 21 days after being laid. Now, it's amazing to think about honeybee development, but since this is a talk on worker bees, I want to emphasize how super cool worker bees are. So worker bees go from egg to adult while passing through a worm stage in 21 days. And when they emerge at 21 days, they are programmed and ready to perform the tasks that they were born to do. So I want to talk briefly, before I even get to the tasks of the worker bee, I want to talk briefly about honeybee development, specifically worker bee development, so that you can get a full appreciation for how amazing workers are. Because honeybees are insects, they have to shed their skin or their exoskeleton as they develop. And that's because their exoskeleton is on the outside of their body. So as they grow, they cannot grow because the exoskeleton limits their growth. So they will shed it. And that shedding of their exoskeleton is called molting. So while this table looks complicated, it's fairly simple. Basically, the life stage in column A undergoes the transformation in column B to become the life stage in column C. Now, I've told you that honeybees will shed their skin. This is true of workers as well. The period between molts is called the instar. It's the growth period of the bee before it sheds its exoskeleton. So let me give you an example of what's happening in this table. When a worker or female egg is laid, you get an egg, A larva emerges from that egg, and it is now a first instar larva. That first instar larva will eat, shed its skin or molt, and become a second instar larva. The second instar larva eats, molts, becomes a third instar larva. The third instar larva eats, molts, becomes the fourth. The fourth instar larva eats, molts, and at that molt, it becomes the pre-pupae. This is the stage that develops under the cell capping. That fifth instar larva, that larva that's standing up, the pre-pupae, it molts a fifth time and becomes the sixth instar individual, which is a pupa. Then it remains in that cap cell as a pupa, at which point, nearing its immersion as an adult bee, will shed its pupal skin. We call that eclosion. When an insect sheds its pupal skin, it ecloses, and it becomes an adult bee. So this talk is about the task of a worker honeybee, but I really wanted you to appreciate how marvelous worker bees are. These last three slides, the slides where I'll show you, the haplodiploid reproduction system, the images of worker honeybees progressing from egg to adult, and now talking to you specifically about what happens as they develop from egg to adult while they molt and undergo these different instar stages. What I'm just trying to do is set the stage for you to appreciate the marvel that is the worker honeybee. Now, I could be giving a similar talk for queens and drones. They undergo similar stages of development. But workers are fascinating because all of what you're seeing on this slide happens before the bee even emerges from its cell. So when we talk about the behaviors of worker honeybees, everybody simply wants to think about their behaviors as adult bees, but they undergo a lot of behavioral transformation while they're babies. They eat and grow and molt, and they eat and grow and molt. They eat and grow and molt and molt and molt and so forth until they come out as an adult bee. Now, let's talk about that adult bee. You're going to notice in this presentation that I have a lot of really good images. Some years ago, I paid a PhD student in our department, Mike Bentley, who's now a Dr. Mike Bentley, to take these pictures for us. He really liked photography, and he was really keen to take some images of honeybees for us so that we could use them in presentations like this one. So I hope you enjoy those images. I wanted to point them out to you because a lot of these slides will have pictures from Dr. Bentley on them, and I just wanted you to be able to appreciate them. This particular bee is particularly interesting because she is a worker bee that has the cordovan phenotype. So one genetic mutation makes it where her exoskeleton, where it would normally be brown or black, it is red. So in this particular phenotype, we get a red or incredibly light colored honeybee. All right. So worker honeybees subscribe to a system, a behavioral system that we call temporal polyethism. Temporal means time, poly means many, ethism means behavior. So temporal polyethism means timed many behaviors. All right. So honeybees exhibit reproductive division of labor. That means there's a queen that does all the reproducing while the workers do all the other tasks. And these tasks are performed in an age-related system. In fact, beekeepers, we call this age-related division of labor. Most of us don't use the words temporal polyethism unless we're in some sort of science class. But for purposes of this presentation, I wanted to introduce you to the concept of temporal polyethism and let you know that you probably know this term more as age-related division of labor. All right. So this age-related division of labor is what's going to fill the rest of this presentation, thinking about it, explaining it, and trying to understand it. I once wrote a column for the American Bee Journal, which is one of our large national bee publications. And in that particular journal, I was writing a series of articles on honeybee behavior and biology. And I had to do a lot of research to study worker honeybee tasks. And one of the things that was fascinating to me is when in leading up to writing this particular article on honeybee tasks, I believed that every worker honeybee performed every worker task throughout her adult life, and that those tasks were incredibly rigid. She progressed from one to the next in a very rigid and predictable fashion. And what I discovered when I was doing research for that article, and now that's turned into this presentation, I've discovered that that is not the case. Not all worker honeybees perform all tasks. And not all worker bees perform all tasks the same amount of time. Some worker bees skip tasks. Some worker bees might even go backwards in tasks. Some worker bees may perform multiple tasks at the same age. So a lot of what follows in this discussion is going to be an overview of the standard progression of tasks and the standard ages bees are when they perform these tasks. And I want you to remember throughout that these are not rigid. They're not locked in place. And you'll understand a lot of that once I finish this presentation, because I'm going to emphasize it throughout my time with you. All right. So the tasks of worker honeybees are largely split into 4 categories: cell cleaning and capping, brood and queen tending, comb building, cleaning, and food handling, and outside tasks. And as bees age, they generally do tasks in group 1, followed by tasks in group 2, followed by tasks in group 3, and so on. This progression, their movement through these tasks, is regulated by physiology, in other words, the chemicals that they have pumping through their bodies. It's regulated by hormones, right? Those chemicals through their bodies. It's regulated by the needs of the colony and environmental conditions. So collectively, physiology, hormones, pheromones, colony needs, and environmental conditions are ultimately collectively what help push bees through these series of tasks and helps them move to the tasks that are needed at any given point in time in the life of a honeybee colony. So probably many of you have seen this graphic from Mark Winston's 1987 book, The Biology of the Honeybee. It's a really good book. And as I've shared with you, there are 4 general broad categories of honeybee behaviors: the cell cleaning and capping behaviors, the brood and queen tending behaviors, comb building, and outside tasks. And within each of those categories, Dr. Winston shares with you the types of specific tasks that are in each of those. So for example, in the cell cleaning and capping task, they'll do some cell cleaning behaviors and some capping brood behaviors. In the brood and queen tending task, they'll tend brood and attend queens. In the comb building, cleaning, and food handling, they'll receive nectar, clean debris, pack pollen, build comb. And in the outside task, they'll ventilate the nest, guard, and forage. So I'm going to talk about all these in detail, so don't panic that I've gone through it fast. But what's most important about this graph is not only what the tasks are, but also the mean, which is the little circle, the common, and the average range of the ages of worker bees performing that task. So for example, the average or mean age of a worker bee performing the cell cleaning task is somewhere around 8 days old, right? You take that little bubble all the way down. But you'll see it's very common for workers that are 0 days old all the way to about 11 days old to perform the task. And even though it's common for them to do it in this range, a lot of workers will continue to perform this task all the way to almost 28 or so days of age. So this graphic shows you what is average, what is common, and what is the whole range of ages in which worker bees will perform that task. And generally speaking, as you move from the uppermost series of tasks to the bottommost series of tasks, you'll see that that bold bar, the one that's the common range, slowly slides to the right, showing that it's generally older and older and older and older bees that are performing that task essentially as they age. But I really wanted to explain this slide to you because to me, it really does a great job explaining that plasticity I was telling you about. The fact that bees don't only perform a task at one very rigid age, that there's actually quite a range of ages that they'll perform that task and so on. So what I've done In the subsequent slides, I've gone through all of the tasks, and I've included those means and average ranges at the top of each slide so that you'll get a good indication of when bees perform a given task.
Our next presenter is Adrian Grew. He really knows his stuff when it comes to nukes. You might think they're simple, but they're not easy. This presentation will help whether you're making nukes, buying, or selling.
G'day, Adrian the Bee Farmer here for the Tocal 2020 online virtual field day, and I've been asked to talk about how I provide quality nukes to my customers. Hi, I'm Adrian the Bee Farmer. I'm a queen breeder from New South Wales. I also produce quality nucleus hives, package bees and beehives for my customers. I pride myself in good quality genetics of queen bees and breeding lines for disease resistance, honey production and docility. I love what I do. I'm very passionate about being a beekeeper. I work with my dog Honey. I wouldn't change what I do for the world. So my dad got me into beekeeping when I was younger. He introduced me to bees and taught me the basics. And then from then I went on to work for some big commercial beekeepers and gain experience in the industry, and decided to move the path of queen breeding and go down that road and rearing quality bees. So what we're doing here is we're just going to open up and have a look at the nuke and go through some of the benefits and features of what I do. A little bit of smoke at the entrance. So all my nuke hives are made up from package bees, shook onto foundation so that my customers are all getting brand new frames, brand new foundation, disease free. So these bees are about 4 weeks old, this nuke. We've shaken 1.3 kilos of bees into this box. We've given them about 3.5 to 4 weeks with a well-bred queen from good genetics that we select for traits like honey production, docility, gentleness, calmness on the comb, disease resistance and pollen gathering. So what we're going to do is I'll just remove a few of these frames. We're just doing an inspection prior to the bees being sold, once some of their progeny hatches and comes through. So these bees have got lovely stores of pollen. On this side we've got a little bit of larvae, and eggs, pollen, stored honey, which the bees have collected out here. Let's have a look for the queen. You see the nectar dripping out of there. Side. Lots of pollen stores on the outside, brood, got some cap brood. Again, lots of honey and pollen stores on the outside. We like to ensure there's plenty of food in the nukes so that when the customer gets them, the bees are well established and ready to eat that honey out and expand. And obviously the brood hatch in their lovely new beehive that they've gone and purchased. It's all cap brood. So again, we mark the queen so that the customer can locate and find her easily in their new hive. And it reduces the risks of them squashing her when they put her back in. And there she is there. I'm just going to pluck her off there. doesn't want to leave me. Yep. So there's our queen, just wandering along there. Nice blue mark on her. And knowing where she is now on the frame, I'm able to put that back in there and push it up against the wall. No risk of squashing her. Again, lots of beautiful stores of pollen and honey. Very gentle bees, nice and docile. So this Nucleus hive here, I'll wait till some of this progeny hatches out and I'll inspect them for the colour, temperament, and I'll do an evaluation on these bees. Check, make sure there's no brood or problems, diseases, things like that in there prior to sale. Then this will be transferred into one of these transport boxes with a closable entrance. Okay, so here we are. We've got a nuke that's been transferred from its timber box into the core flute transport box. And what we're going to do is we're just going to tape up this box, install it in the car for the customer so that they can go home and install and transfer it into their hive. So on top of my box here, I've noticed I've got all my markings here. We've got PD, Q, M, E, B, L, P, H. So PD basically means that this hive's had its pest and disease inspection. Q means that it's got a queen. M means that the queen is marked. E for eggs, B for brood, L for larvae, and there's lots of pollen and honey stores. I've also got the date here, 29th of the 9th, 20, and it's been signed off by myself to say that I was the one who inspected this Nucleus hive. This Nucleus hive, it says nuke number 86, so this particular hot nuke has come from the timber box 86, so if there was to be a problem with this later on down the track, I'd be able to, again, trace back to number 86 and then check that box and equipment in that box. We've got the Beekeepers registration number that it's going to, NG218, and then we've also got A Gru, which is my name there because this is actually going to be one of my Nucleus hives to install in one of my boxes. So what we'll do now is I'll shut the entrance up and we'll tape it up and I'll show you how we put it in the car. These transport boxes, it's very, very important that we tape these sides all closed. I also like to tape the front here, or you can actually use staples, put across the front. These do have little locking tabs that you have to pull out, but I wouldn't trust them in a car if there was an incident. So I'm just going to tape the sides. As you can see, these nukes have good ventilation in the front and rear. So now what we're going to do is just close this, push that little bee in there, close the front entrance to the ventilation setting there to make sure no bees can come out. And what I'm going to do now is just have a look up inside. Sometimes you can use your bee brush to brush the bees off if you have a rogue like this one here. We just want to get him away, or her. And that's now ready to go in the car. Okay, so we've got a late model European car here. I'll just check my entrance is all closed up. There's one rogue bee there that I want to get out. Away. Generally, if you do have a bee, they will sit on the ventilation. So as you can see here, we've got air conditioning vents in the back, so the bees are going to be nice and cool. So where's wedge the box in there. Yeah, that box is not going anywhere. There's good ventilation over here, nothing blocking that. And also on this side, the ventilation's not been blocked. Well, the door, when I close it, it's not going anywhere. There's no airbags in this part of the vehicle. So this should ride quite safe and secure. Okay, so here we are. We've transported this Nucleus hive to this location. The box is set up ready to go. I'm going to go through the installation process and just cover a few tips and problems that I've seen people come across. So one thing you want to do is have your hive set up. The frames are in there, the excess frames. So we've got a 5-frame nuke. This is an 8-frame hive. So we've got 3 spare frames in this box ready to go. I've got a feeder on top there. I've got 2 entrances that are open and I've got 1 that's closed, just to reduce the entrance size down so the bees have less area to guard and look after it as they're getting established. When you're placing your nuke at home, we've just got it out of the car, we really want to open it up pretty much straight away. You don't really want to leave the bees to get hot and cook and stress any more than what they are. So you've got 2 options of placement. You can either sit the Nucleus hive directly on top of the box they're going into, or we can sit it nice and comfortably next to the hive. There's no ants here at this location. If it was up on a stand, obviously you'd probably better off to put it on top. And then what I'll do is I'll just give them a bit of smoke around the entrance. And I'm just going to open the entrance here to let the bees fly. So the last thing you want to do is open and try to transfer the bees after they've been bouncing around in the back of a car. The bees will be quite stressed, quite aggressive at this stage. So you really want to open them up and let them fly for a couple of hours, orientate, let them settle down. Okay, so we've allowed these bees to fly for about 4 hours. They've settled right in, they're nice and calm. So what I'm going to do now is we're just going to transfer the bees across. As you can see, the entrance is facing the same way as the entrance on the main box. Take out our transport tape off here. Bit later in the day here now, and these bees are in a perfect, nice, shaded location for this time of the day. So what I'm going to do is 1 frame at a time, pull that out, and just put it in the same position and orientation as the other frames. There's our brood frame. Lovely. Just having a look for a marked queen inside the box. We've got some spare bees here. So all I'm going to do is just give them a shake out in front of the hive and they'll work it out and orientate their way back inside. It's important to wear all your gear, and I do recommend you wear gloves as well, especially if you're starting out and you're not used to bee stings and handling bees. We put our feeder on there, which we'll come back later on and give the bees a feed of sugar syrup. Put the top of the box there. These boxes are very handy to keep and hold on to if later on you need to catch a swarm or a neighbour rings you about a swarm. They're very handy to keep us a few spare frames of foundation in this box, or later on if you need to split because they're finding swarm cells. They're very good, and it's easy as that. Hi, so we've just moved down here into the shade, get out of the sun, and we've been joined by Honey Dog. She's often out running around beekeeping with me. When you pick up your nucleus hive, it's best to do it in the morning, just before the bees start flying and it's nice and cold, or late in the afternoon, just on sunset as all the field bees are coming back in. If you pick them up during the middle of the day, half the bees are out flying in the field, you're actually going to leave a lot of the bees behind. So it's a good idea to pick them up early in the morning or late in the afternoon. And I personally like to go through every nucleus hive with my customer, and I show them the eggs, the larvae, the capped brood, a marked queen, honey stores, pollen, no diseases, and make sure that they're confident and they're happy with their purchase. And then I assist helping them tape them up, installing them in the car in a safe location, not on the front seat or where airbags can impact the bees, and make sure that if they've got to travel overnight, wherever they get to halfway, they do let the bees out of the car, they open them up in a paddock or a field somewhere, they allow the bees to fly for the next day, close them up that afternoon, and then continue on their journey to make sure they get home safe. Transporting bees can be very, very dangerous and very risky, but if it's done in the right way and people think about things and plan your trip as well, it is quite a safe thing to do. Bees can handle cold quite well, so by transporting bees at night time or early morning in the cold, it's very suitable to move the bees. If you've got a hot nucleus hive in the back of a car with no air conditioning on, it's not going to last the trip. So make sure you've got air conditioning on. They're in a nice shaded spot in the vehicle where they've got access to a bit of cold blowing air around them. If you've decided to get into beekeeping and you've ordered a nucleus hive from a supplier and you're going to pick them up, if you're not sure how you react to bee stings, take someone with you that does. Someone that knows it's had a sting, that knows that they're not anaphylactic, and it's also a great idea to carry an EpiPen. So I talked a little bit about how we make up our nukes and about how we're putting everything onto brand new equipment. Now that might not be a viable option for a lot of people, but I just stress, don't use old brood combs and old frames from your production hives and use them in nucleus hives to sell to customers, kind of using customers as a way to replenish the frames in your beehives. So even if that means you do a thorough pest and disease inspection on your beehive and you lift frames up and turn it into a double brood chamber and put nice new foundation and new frames in the bottom of a disease-free hive, allow the bees to draw comb, allow the queen to lay eggs, then move those frames across into a nuke, add a nice new seasonal queen, good temperament, mark if the customer requires it, and at least then you've got the confidence that you're selling good quality bees. You may have noticed all my nukes have a number on them. So what I'm doing is when I make up my production hives, which are also numbered the same, I shake bees out of production hives and harvest bees, and then I'm noting down, record keeping, what hive the bees have come from and what nucleus hives the bees have gone into. So if there is a problem down the track, there's some sort of traceability back to where it originated from, and I'll be able to find that quite quickly. By exchanging brood combs from diseased hives, you're just spreading chalk brood or AFB, EFB, all those sorts of diseases. Another point on that is when you're purchasing your bees, I highly recommend people ask for a certificate number off some sort of pest and disease management course, just to show that the person that you're buying the bees from is qualified in pest and disease identification and are doing the right thing in the industry. So this course was done online through the National Bee Biosecurity Program, AgriFutures, Australian Honeybee Industry Council and Plant Health Australia have all supported this course and put towards that. Otherwise, I've also done some fantastic courses at Tocal College on pest and disease management. They run a great course for beekeepers and I can highly recommend to go along and do their course. Another point to add is it's important to ask the person that's supplying or making up your nucleus hive where the queen comes from. The queen is the heart and soul of a beehive, so by ensuring that there's good genetics in that queen, that's what's going to come out in your beehive. The last thing you want to have is a a queen that has a bad temperament, has an aggressive nature, doesn't produce honey, or a swarming tendency where they can become a nuisance to the public and people around. So make sure you ask what race or subspecies the bees are, and is that suitable for your climate, where you're located, and the sources that you're going to be providing the bees. Do your research, look into the different pros and cons of different races of bees. I personally breed Italian stock. I find they're hardy, they're good for the weather, they handle the hot climate of Australia, but in different parts of Australia that might also change. As bad as COVID is, I hope it's allowed everybody to take a breath and spend a little bit more time looking after their bees and getting back to their roots and enjoying doing what they love and they're passionate about, and being closer to your family. To get in touch with me, Adrian the Bee Farmer, you can go to my Facebook page or my website www.thebeefarmer.com and send us an email. We'd love to hear from you.
Next we have Claire Densley and Martin Han from Buckfast Abbey in England. They'll be presenting on pheromone communication in the hive. This is really important as it helps us to understand what's going on in that colony and why. Thank you.
Hi Kevin, and hi Tocal. I'm Claire, and
I'm Martin. Hi.
we are the Buckfast Abbey Bee Department, and we're recording this in our bee barn. And we're doing two talks for you, well, the same talk but split into two half-hour sessions about pheromone communication. So this is what we're going to cover in the two talks. What is a pheromone? Why are they so important to honeybees? How pheromone communication regulates colony life, and how we as beekeepers can use pheromones or our knowledge of pheromones to help us manage our colonies.
So I guess, Claire, the first thing we need to clear up is what exactly is a pheromone?
Good question. Pheromones are widespread among insects, vertebrates, and are present in plants, fungi, slime molds, and algae. Even humans, although we do our best to mask them, use pheromone communications. And basically, it's tiny amounts of a very strong chemical compound which is secreted from our bodies, in our case, in tiny amounts, which would elicit a reaction from another, in our case, person or organism of the same species. So they're best known as sex attractants, basically. That's how we understand, or our knowledge of pheromones is basically as a sex attractant. But in actual fact, it's much more complex and far-reaching than that. So we've got two glandular systems in our bodies. They're either exocrine, which means that the glands open onto the skin and chemicals come out actually onto the skin, or there's the endocrine system, which are chemicals which communicate inside our bodies.
So that would be hormones?
Yeah, testosterone, estrogen, all those things which regulate the internal functioning of our bodies. But the exocrine glands in us would be, examples would be the sweat glands, salivary glands, mammary glands, tear glands, in the stomach pit, and the anal glands.
So all these glands, they look the same? They're just under the skin surface, I guess?
There's some examples of the types of glands. You know, they can range anything from simpler tubular glands to quite compact, complex tubular acinar glands.
Goodness.
And we pick we pick these chemical signals up either through smell or through taste. And it's very apparent if you're a dog owner, if you own a dog and you go for a walk in the park and it meets another dog, the first thing they do is sniff each other's bottoms and even lick that area. And it's not that they're being rude particularly, it's just they're picking up pheromonal chemical signals about all kinds of things.
It seems to me, though, that as a human race, we've sort of rather lost, we've fallen out of love with our pheromones.
Yeah,
We spend a lot of time sort of using underarm deodorant and things.
yeah, we don't like the smell of sweat, or we profess that we don't like the smell of sweat. In actual fact, on the internet, now I only know this from the internet, I haven't been to one, there are such thing as t-shirt parties. So people who, it's like a dating agency, people wear a t-shirt for 3 or 4 days without washing. Then all the t-shirts are put in plastic bags, and people go and sniff the plastic bags, and they pick one that they are not aroused by, but like the smell of best, and then that's their date for the evening. And it's reckoned that we are attracted to our partners by smell or pheromonal communication much more than, say, their personality or how they look. It's true.
I'll take your word for it.
Even plants communicate via pheromones. So I don't know, that's one of them. There's a beetle called the mountain pine beetle, which burrows into the bark of pine trees, and therefore eventually the tree will die. But the tree can produce a resin or to protect the wound, which also will trap the beetles and kill them. And the smells coming off from this resin will actually communicate with the tree next door to tell it to produce the resin, so to protect itself from these beetles. So it's possible that plants can communicate to each other to protect themselves. It's plant communication, plants between plants.
So honeybees then, pheromones vital to honeybees?
All insects have developed pheromone communication to quite a sophisticated level, but because honeybees live in huge numbers in quite small complicated spaces, so it's a very crowded space they live in, pheromone communication has become very, very important as a way of regulating the colony. And the trendy way of talking about this big family that the bees live in is a superorganism. It's a large number of animals of the same species which live together and which cooperate. So there are lots of individuals, but they operate as an organic whole.
So presumably then, Claire, you've got somebody in charge that's issuing orders. So the queen gives off pheromone and tells all the bees what to do, I guess.
Well, the queen has a great influence on the goings on of the superorganism, but in actual fact, she doesn't. That's not the way pheromone communication works. If we just go back to being a superorganism at the moment, it's a group of closely cooperating animals which behave as a unit. So they're all individuals, and the way that the way that conflict is avoided in this big family is that there's the worker bees particularly are differentiated into castes. So the queen does nothing but lay eggs. So that's her role, and the workers do all of the other jobs. And the other thing is there's cooperative care of the young. So the division of labour, there's a division of labour.
So the workers then have given up their right to reproduce just to look after the queen. So they only get their genetics into the next generation by helping the queen.
Yeah, by helping the queen. But the point is they all do make their own individual decisions, but somehow they're operating as a whole as well. And to answer your question of 2 slides ago, the queen doesn't issue orders in the way that, oh, you lot go over there and get me that nice pollen that I like, and you lot go over there and do a bit of tidying up. It doesn't work like that. It's more that her pheromones influence the behaviors that the bees have. So her pheromones would suppress some behaviours and stimulate other behaviours. So it's more about feedback systems and thresholds being gone above or dipped below. We'll expand on that a little bit more later. So bees do communicate via sound as well. Bees do make noises which are understood by other bees, but they don't have a voice book, so they don't talk through their mouth as such. Would you?
Yeah, I think what they do basically is use their muscles in their thorax there, and they vibrate them, and usually press their thorax and their abdomen down onto the comb, and they use that, particularly empty comb, and they use that as a sounding board so that they can pass sort of vibrations as much as sound through the colony that way.
And even they will mount each other and actually press their thoraxes against another bee, as in the dorso-abdominal ventral dance.
Yeah, and they have sensors within them that pick up these sound vibrations. They see it as very pure sound, not like we would through our ears, but they pick it up through organs in their legs, their subgenual organs, and also on their antennae. And we'll talk more about antennae a bit later on because they're really important to bees.
And there is quite a range of sounds as well, isn't there? There's piping by the queen, and then there's the quacking in the queen cells, and then there's all kinds of low, and we all know as beekeepers, when you open a hive up and they haven't got a queen, there's like a low roar that we can hear.
That's right. And you know, we all know when we've had a hive open for too long because the pitch of the buzzing changes. You know when it's time to get out of there.
Yeah. They also use body language, or they would pick up information through watching each other move. But we have to remember, you know, there is the famous waggle dance. You have to remember this is all happening in the dark. And the bees that attend the dance, this is the scout bee, which is indicating to the bees where to go. The bees that are attending to the dance often get very close, and they're picking up vibrational signals as well. And also they're touching and picking up information through their antennae. So it's not just a visual thing, and very possibly there is smells going on there as well, because very often she's giving out free samples of food.
But really, we've talked about sound and we've talked about dancing, but for bees, the bulk of their communication is through pheromone.
I think for any eusocial or any superorganism, they say that 90% of signals used are pheromonal or chemical. And they can be used in combination with the other ones, but it's the main way that the bees communicate, and or any termites, ants, any of those big colonies.
Okay, so where's the bee's nose then? Because we know that they haven't got noses as such like we do. So
no, they don't have noses. They don't have ears either, do they?
No.
Their main sensory organs are, of course, their antennae. And these are terrifically mobile things. If you watch bees in the hive, they've got this beautiful, if I can just get my pointer, they've got this beautiful ball and socket joint here, and these antennae can swing around and be pointed in any direction. And then you've got all these different segments. I can't remember how many there are. Do you remember how many there are?
About 12, I think. But the drone has one extra one, and I can never remember.
And if we looked at these segments close up, you would see that they're covered in sensory organs. Just before we go on to that, we're going to look at the bee's eye, because bees is not just the antennae on the bees. There are sensory organs or sensory receivers all over the bee's body, even the eyes. This is a close-up of the bee's eyes, and you can see in between each of the compound lenses of the eye, you've got hairs which measure, when the bee's flying, it measures the wind direction, so she can gauge how far she's gone and how fast she's going. So the bees are covered in sensory receptors, but the antennae are really, really specialized. So this is a close-up of one of the sections. You can see it's covered in little pits, little pegs, little hairs of various lengths, and all these separate sensors are picking up information from different things. So these pits here, the sensilla placodia, are for smell.
Yeah, they pick up individual molecules will go down through a porous membrane there onto the receptors below. And as I say, they're Sensilla placodia. And the little pegs there,
These
they're
ones.
Sensilla, yeah, they're Sensilla bassiconica, and they are associated with taste. So if you think about it, with a human being, if we want to touch something, we tend to use our fingers. If we want to smell something, we use our nose. If we want to taste something, we use our tongue. But bees do it all with the antenna. It's a wonderful sensory organ for them.
And these pits, the Sensilla placodia, they're very similar to what we have on the inside of our noses to smell with. And worker bees have 2,700 on each antennae. The queen bee only has 1,600, but the drones, and Martin will explain why this is so important later, have 15,000 on each antennae, so 30,000 in all, because they really need to be sniffing out virgins, but Martin will expand on this later. So apart from their antennae, they also have sensory receptors inside on their mouth parts, on their mandibles, because they would touch with those. They also have them inside the mouth, so a sort of taste area, but amazingly on their legs and on their feet. So as they're walking around the colony on the comb or touching bees, they can smell and taste with their feet.
So when you pull out a comb from a hive, you're looking at it and you've got these bees wandering around on it, or sometimes just motionless. Are they picking up senses all the time then? Is that what it is?
Well, the motionless ones are probably just resting, but the ones that are wandering around, it's called patrolling. And they don't seem to be doing any job in particular. You know, when you look at a comb, you'll see bees that are tending the young, and you'll see bees cleaning out cells or looking after the queen. But these ones that seem to be just aimlessly wandering around are actually picking up pheromone chemical signals about what to do. So if a bee one is patrolling and she wanders over a larvae and that larvae is ready to be fed, needs feeding, it will give out a pheromonal signal which will tell that bee what kind of food it needed, and it needed feeding. And if the bee was a nurse bee and she had the hypopharyngeal glands all developed, that's what she would do. So they're continually just wandering around or patrolling and picking up information. And if a job needs doing and it's ready and it's got the wherewithal to do it, it will do that little job. But they don't work for very long. It's not one bee cleans out one cell. A bee might clean out a little tiny bit of a cell and then go and have a rest and have something to eat, and another bee will come along and do a tiny bit more of that cell, and it might mean 30 bees actually clean out a cell. So
well, we always think, you know, that the analogy is busy as a bee. So you're telling me that they do more sleeping and resting and that sort of thing.
They don't need to, because there's so many bees. There's so many bees. They only need to be doing little bits and bobs of things, and everything will get done because they're communicating all the time. That, you know, they're only doing a job that needs doing because of this pheromone messaging. In fact, in 1952, there's a guy called Lindauer who did a lot of bee research, and he observed one worker bee in an observation hive for 177 hours. And he just watched that one bee. I guess he had a bit of help. I don't know how he could stay awake for that. But anyway, of those 177 hours, 56 hours, she was simply patrolling the nest. This doesn't mean that she was doing nothing. She actually spent, according to Lindauer, 69 hours and 53 minutes resting, or loafing around, as he put it. So it's not a bad life being a bee. You do get lots of rest and you do get lots of snacks. So returning to pheromones now. Martin's going to talk you through this one.
Okay, so on the screen there you can see we've got pheromones that act in two different ways, releaser and primer. So if we look at releaser first, what a releaser pheromone does is it causes a very sudden and quick change in the behavior of the bees around it. So a really good example of that would be sting pheromone, which is isopentyl acetate. And we know that when a bee stings, it releases some of this isopentyl acetate, and that encourages other bees to come and sting at the same site, which is why if you get stung perhaps once, it may mean you're going to get stung 2 or 3 times in the same site. So that's a releaser effect of a pheromone. On primer, that's a much more long-term thing. And as we'll see a bit later on, the queen exudes pheromones from all over her body, and they combine to produce what we like to call queen substance. And that queen substance has the effect of preventing the ovaries of the workers from developing. So that is a much longer term behavioral change. The interesting thing is that we will also see that queens give off a pheromone from her mandibles, which we refer to as queen mandibular pheromone. And that can act as a releaser or a primer, depending on the type and age of bee that are picking up that pheromone. So it's not just the pheromone itself, it's the bees that are responding to it that make the difference as well.
So we're going to look at the queen bee in more detail. She is, as we said before, she isn't Scott Morrison. She doesn't issue orders, or she doesn't have a sort of parliament where they agree on what's going to happen with the colony. But she is very influential. So she isn't a ruling monarch, but she's more than just an egg-laying machine. And we're going to look at the research that's been done on queen pheromone, because probably it's been done on queen pheromone more than any other chemical. So queen mandibular pheromone, the pheromones, or the cocktail of pheromones that she releases from her mandibular glands up here in her mouth, were first discovered or isolated by a guy called Colin Butler in the 1950s, around that time, I think. And he kind of, I'm not a chemist at all, so these mean nothing to me. I think Martin can expand on them a little bit.
Okay, you've got the two key chemicals that he isolated and discovered were 9-oxo-2-decanoic acid and the 9-hydroxy-decanoic acid. The names have changed over the years, but if we abbreviate them to 9-ODA and 9-HDA, we won't go too far wrong. And he basically was the first guy to understand that these chemicals played an important role in how the queen manages to control the colony. He also found out one very important thing about them, and that is that they are have low volatility. And if you think about most scents, perfumes and things like that, you imagine them wafting around in the air. But these substances are very oily, they are low volatile. And from that point of view, that means that they have to be moved through the colony by the bees, and we'll look at that a little bit later on. But that was one of the key things that he found out, this low volatility, and we'll come back to that several times. It's very important.
But she doesn't just produce, since then we found out she doesn't just produce pheromones from her mandibular glands. There are glands all over her body. So we've got the salivary glands, there's glands in her head, there's glands in her feet, her thorax, and there's a whole load of them down in her bum area, or in this bottom end. So it's a much more complex language than we first realized.
And the interesting thing there is that the queen, as we've said, is now a specialized creature, but her hereditary roots were that she would have come from solitary or semi-social roots. Those bees, those queens would have had to have been a bit more of a jack of all trades, but the queen...
Jill of all trades.
Jill of all trades, yeah. So we need to remember that her glands in her head don't have to feed larvae, for example, so they can be more specialized to produce these pheromones that help control the colony. And looking at the rear end there, her Koshevnikov's gland, her Dufour's gland, she has a separate ovipositor and sting, whereas in solitary and semi-social bees, those sting chambers and ovipositors are combined, but therefore she's allowed to have a much more specialization of glands and secretions. And that's really important to how she helps to hold the colony together.
And the other thing is, very often these glands aren't working independently. Very often they're working synergistically. So you can imagine if a gland's being produced in this area, it's probably going to mix up with, I think the Koshevnikov and Dufour's gland probably work synergistically together to be an attractant to young bees. So very often glands are working, glands from here and glands from here would be working together to get quite complex behavioural patterns from the bees. So the summary really is she's producing this synergistic multi-glandular pheromones, and really it influences most of the behaviour within the colony. She's not conscious of that though. It's not a conscious thing. She's just oozing these out anyway, and then the colony and the bees are picking them up again unconsciously. It's not. We always try and translate bee behavior anthropomorphically, like the bees want to do this and the bees want to do that and the queen wants. It doesn't work like that in the animal world, and certainly not with honeybees.
So I guess what we need to look at, Claire, is we know this queen is giving out all this pheromone, but it's got to be transferred around the colony, and as we said, it's low volatile. It's not going to waft through the colony on its own.
So one of the primary things the queen needs to do to get these pheromones out into the colony is she has to get bees to carry them or message them about. And the first thing she needs to do is get bees around her. And the bees that she attracts around her are young bees. Young bees are particularly under 6 days old are attracted to the queen. And this is the glands down in this area, the Koshchevnikov and the Dufour's gland, attract these young bees in because she can't do anything for herself. She's lost the ability to feed herself. She does groom herself a little bit in that she's spreading these oily pheromones around her body, but she needs to be fed and she needs to be looked after and cosseted. Even they remove her feces. So the first thing is attract the young bees in, and once they're in there feeding her, and you'll find that if you've ever seen this in an observation hive, they'll touch her with their antennae and they're actually picking up the oily substance which is secreted from the glands, and it will be on their antennae, and then that bee will pass it on to another bee via antennal contact, and that bee will pass it to another bee, and so it will get disseminated throughout the whole colony. But it's really important that these bees around her are young bees, because they're not going to do her any harm.
Yeah, we've often thought that bees pass pheromone around the colony by trophallaxis, which you can see on the screen there, the food sharing. But that really takes too long. And these retinue bees, that they have to move this pheromone around very quickly. The pheromone will last on their antennae for about 30 minutes. And they need to get this disseminated out to the four corners of the hive. And so antennal contact seems to be much more important, so that they're picking up the chemical, this oily chemical from the queen, and then they're rubbing antennae with other bees as they go through the colony, about 30 minutes, and spread it around. But the key thing there is that the queen is pumping out this pheromone all the time, every minute of the day.
Say that. Yeah, it's coming out of her all the time, so she's producing it all the time. So this signal that the queen is there and she's fit for purpose is constantly being spread around the colony.
And they say that if you take the queen out, then the bees will know within half an hour.
They'll start being nervous and a bit agitated, and maybe even start converting larvae to be a new queen.
The other thing you notice is if you take a queen out during an inspection, you pop her in a cage, and you put the cage on top, all these are
So we've learned quite a lot about the chemicals that are issued by each gland, and you'd think they would be able to say, well, this chemical makes this behaviour happen, but it's not as simple as that. If we just look at the list of chemicals which they've isolated from Dufour's gland, and actually they're still not really sure what Dufour's gland does, do they? They used to think it was it released onto an egg so that workers knew if it was queen-laid egg or a worker-laid egg, but that's kind of like gone by the by now. Look at all these chemicals here. And these are morphing and changing. They're organic chemicals. They're morphing and changing all of the time. So to isolate specific behaviors to specific chemicals is too simplistic.
Yeah, and this is why people sometimes say, well, why can't we use some synthetic pheromone to boost things in the hive or to alter things? Because we're a very blunt instrument in what is actually a very fine-tuned machine.
And we're going to just quickly, where time taken away here, we're just going to quickly whiz through some of the effects of queen substance, and I'm using the term queen substance because I'm referring to the whole cocktail of chemicals that the queen's giving off, not just queen mandibular pheromone, not just 9-ODA or 9-HDA. So the queen substance can inhibit queen rearing. That is, she stops them making another queen. So all of the time, there is an instinct, an innate desire in the hive, for, like a default activity, if you like, to be rearing a new queen. If the queen did accidentally get killed, this would kick in and it would save the colony. But her queen substance suppresses that instinct. So as long as the queen is there and she's giving out sufficient amount of pheromones, they won't raise a new queen. It's a kind of default thing. So if the queen pheromone dips below a level, the bees may supersede, or if the queen was taken out altogether, or we killed her accidentally, they would rear a new queen, probably from a 2-day-old larvae. And that's really important in beekeeping, and we'll expand on that later. Also, the queen substance, along in conjunction with brood pheromone, suppress the ovaries from workers from developing. She also suppresses drone production up to a point. Now that sounds a bit weird, but when a colony first establishes in spring, they don't need drones, they need worker bees. So if she's had a brood break in the winter, the first thing she does is make worker bees. And then when there's enough worker bees, that's the point where she makes drones. So her pheromones will stop the worker bees making drone cells for her to lay in, because they're the ones that make the cells for her to lay in. And then when they're all getting a little bit less queen pheromone, because there's more of them and it's getting spread, they're all getting a little tiny bit less of the cake, if you like. That's the point when they start making drone brood for her, or drone cells for her to lay in. And similarly, it's at the same point that they start making queen cups, usually. And also, to a certain extent, she can stop the nurse bees from going on and becoming foragers for about 6 days. So she can keep bees young around her to look after her for about 6 days. Thereafter, the pheromone doesn't work on them anymore. I'm going to let you take the next section, Martin.
Okay, so apart from those inhibitory effects, it also has stimulatory effects. So we've talked about the attraction of the young nurse bees towards her for the retinue that forms around her. But it also plays a very important role in sex attraction in the mating process, and we're going to talk more about that in the second part. It also has the effect of increasing and encouraging brood rearing and preparation for cells. And what we mean by that is that when we look in a colony and we're expecting a new queen to develop, then we quite often say, oh, the cells have been prepared, and sometimes we say they've been shined up. They usually have an appearance where they've been laced with pheromone, which will encourage the queen to go and lay in there, and those cells we say have been well prepared. The other thing that it does is encourages the bees to forage and to go and collect more food. We often say, certainly in this country, that if you see pollen going into a colony, it's a sign that everything's queen right and okay. I'm not sure that that's entirely true, and I've seen pollen going into colonies that aren't actually doing that well.
Bees have behaviours which they're hardwired to do. It's just that the queen stimulates them to do much more gusto and enthusiasm. So pollen will go into a queenless colony because that's what they do. They collect pollen. But if you've got larvae to feed, the queen will be much more efficient about that and do it with much more zeal and purpose.
Yeah, one thing definitely a well-mated queen does encourage is comb building. And if you've got a queenless colony or a colony that's waiting for a virgin queen to get mated and take over the colony, they won't draw comb. You can give them frame station, but they won't draw.
Wax columns, really, isn't it?
I think so, yeah. So that's certainly one to watch out for. I think we're about on time, aren't we, Claire?
Yeah, we're going to let you go and have a bit.
Up next, we've got Leonie Martin, Plant Biosecurity Officer, talking about biosecurity emergency response training.
Hi, I'm Leonie Martin. I'm a Plant Biosecurity Officer with New South Wales DPI, and I'm here today to present to you a little bit about the Beekeeping Emergency Response Training course that has recently been created. So why did we create this new training course? It's actually a nationally accredited training unit of competence, which is great. It's actually to increase the number of competent honeybee experts to call upon in the event of a bee biosecurity emergency response. So it's not just about training additional beekeepers to help us in an emergency response, it's also about training government staff and industry people as well. So it's about improving people's skills in honeybee emergency management. It's to teach people how to work safely in a response situation, how to identify, access and use the required information in a honeybee response, and to be able to adapt to change and communicate effectively in those situations. So the BERT course itself consists of two parts. The first part is some online training, and you will have to do some multiple choice questions and assessments in that online component. It would generally take about 2 to 3 hours to complete, I think. And following the completion of the online training component, you would then be required to do a practical one-day face-to-face workshop. And that one-day face-to-face workshop basically consists of 3 parts. So the morning session would be a recap of all the online training that you went through to refresh your memory. After that, you would then have a personal protective equipment and decontamination demonstration and practice session. Followed by, after lunch, there'll be some outdoor practical assessments where you'll be required to suit up in your PPE, decontaminate onto a site, collect and take samples, and then decontaminate off that site. So the course covers very generally the key principles of a biosecurity emergency response. Most responses are managed by objectives, so it's setting, communicating and achieving objectives, where the whole response has a single aim underpinned by a number of objectives that describe how the aim will be achieved. And so in order to keep objectives consistent and everybody on the same page, objectives must be SMART. So they must be really specific and clear for people. They must be measurable, they must be achievable, got to be relevant and time framed. So they actually have to be proven to be able to be achieved. Within an emergency response, there's all types of different information that may be required. And again, that will depend on what level you're working at. But for the purposes of BERT, you'll most likely be out doing surveillance work most of the time. But some of the information required in an emergency response will be the legal documentation and additional resources. So in the case of a bee emergency response plan is one of the key documents that you would use there. You'll also be required to provide personal information, which will be part of your induction into the response. And then you'll also be provided with some role-specific information, which will tell you about the job that you've been employed to do. So part of the course is being able to carry out and manage your own work. And like I said, most of the work that will be undertaken will be surveillance work. So early detection of exotic bee pests and diseases reduces the response time to eradicate or contain the pest or disease within that area. And some of the first steps that we need to do are have a confirmatory diagnosis of what the pest or disease is that we're dealing with. Is it actually considered under legal requirements an emergency plant pest? We need to establish the extent of the infestation. We need to prioritise the surveillance locations based on the extent of the infestation. And we also need to determine the actual size of the quarantine zones that we may have to put in place. So when you go out into the field, you'll usually be following work instructions on what to look for. You'll be capturing data, so you'll be recording the presence, absence and population levels of pests. You'll be collecting samples and submitting them for testing, quite possibly. One such example would be for varroa mite, and for that you might be looking for sealed brood cells. Pupae should be removed with a comb or forceps and inspected internally for reddish-brown mites. And you should implement standard in-hive varroa surveillance procedures. So you'll normally go out as a group of at least 2 or 3 people. If you're employed within a BERT situation in an emergency response, you'll always be accompanied by another New South Wales DPI, probably a bee biosecurity officer. So there'll always be 3 of you. So you'll never ever be put out into the field on your own without some supervision and support. Again, complying with biosecurity requirements. Part of all those requirements are following standard operating procedures, doing what you're told, following work instructions from your supervisor. You'll most definitely have to wear appropriate personal protective equipment at all times. If you're dealing with chemicals, then you must be able to read or have read to you the product labels, so you know what the chemical is that you're dealing with. You need to report anything that you believe to be a biosecurity breach immediately to your supervisor. and you need to keep accurate biosecurity surveillance records if that is part of your job. So we're quite big on personal protective equipment. It protects you from bee stings, possible injury or illness. It prevents the spread of pests and diseases, and it must be worn at all times when you're working in an emergency response situation. Before departing your work premises, whether it's a local control centre or a forward command post, you must ensure that you have all the appropriate PPE packed and ready to use to take with you. If you don't have anything that you need, then PPE is sourced and supplied generally by the logistics team. You will be trained in the correct use and fit of PPE, and you will also, any faulty or damaged PPE should not be used and it must be replaced. So a big part of that one-day face-to-face workshop is training you to correctly use and fit PPE. So personal protective equipment that you will be provided with would be a bee helmet, a bee veil, nitrile disposable gloves, disposable overalls with elastic cuffs or wristbands, and you'll be required to provide your own sturdy enclosed leather or rubber shoes that cover the ankles. So some of the beekeeping equipment and tools that you'll need to use will be a hive tool, a smoker and ignition fuel, miticide strips, sticky mats, a comb scratcher and forceps or tweezers. You'll be provided with a fully stocked decontamination field kit, which will include stericidal water solution, so 70% ethanol. It will also have the PPE in it and a first aid kit with an EpiPen, and it will also have plastic containers to collect any samples in. All these beekeeping equipment and tools will be provided to you in an emergency response situation. So this illustration is just to give you a little bit of an idea. Not every situation is going to be set up exactly like this, but the important part here is that there's a clean side and a dirty side. And so basically whatever starts off on the clean side can go onto the dirty side, but whatever's on the dirty side must be decontaminated, cleaned and or bagged before it leaves that dirty side. So nothing dirty should be coming off into the clean side unless it has been decontaminated first. And that's just a really good illustration of how to set up a field decontamination site. Part of the field surveillance will be, once again, data capture. It may generally be the responsibility of your staff team leader. However, you may have to record some details. You'll generally be provided with reporting forms or an iPad. You'll definitely have an iPhone to take photographs of anything you need to maybe get an identification of. And Biomap is one of the mapping programs that we use in order to locate the hives and owner details, etc. So once you've been out and done all the work for the day as part of a biosecurity response, you'll generally come back and participate in a debrief for the day. Sometimes it may be at the end of the week or basically at the end of the response, but it's basically to assess what worked well and what didn't, what possible changes could occur for next time. And it's basically just going through the whole event and seeing what worked well, what didn't, what everybody got out of it, and any suggestions for improvement. It's also a big part of making sure that everybody is okay. Quite often biosecurity responses can be quite emotional for some people. So it's important that everybody debriefs and touches base. In summary, the Beekeeper Emergency Response Training course was developed to improve New South Wales preparedness for if and when exotic bee pests or diseases arrive. It's to increase the number of trained people to assist us in a honeybee emergency response. More people on the ground in a response enables us to have a quicker response time, and it also helps people to actually gain a nationally accredited training unit of competence, which is a great outcome. So look, thank you very much for your time today. That's just a really brief overview of the training course that we've created in the hope of improving New South Wales preparedness to better cope with a honeybee exotic pest or disease outbreak. Thank you very much for your time. Bye.
If you're not a member of a beekeeping club yet, this next talk by Emma McPherson from the Hunter Valley Amateur Beekeeping Club will be of interest to you. She goes through reasons why you should become a member of a local club.
Hello everyone, my name's Emma and I am the event coordinator of the Hunter Valley Amateur Beekeepers Association. I'm briefly here today just to talk about our club and how we help beekeepers and share our knowledge with everyone. The Hunter Valley Amateur Beekeepers Association actively promotes beekeeping and offers a wide range of support and assistance. We have over 200 members, all of all ages, who have different levels of experience and a wide range of backgrounds. Some have one hive and some have many hives. Some have native beehives and some have honeybee hives. Our club provides education and guidance to all our members. We have days in our apiary where you can go along and assist with opening of the hives and assessing how they're going. We do extracting honey in our extraction shed. We have bottling, labelling honey, and we offer peer support, mentoring and advice and assistance to new beginners. We do conduct beginning of bees courses, and we have workshops on, we might be mead making or making wax wraps or anything to do with bees. It might be repairing a hive. It might be making cream honey. There could be really whatever topics that people would like to have workshops on, and we'll see if any of our members are available to conduct them. At each meeting we have guest speakers on topics such as pests and diseases, extraction facilities, queen breeding, or the current code of practice. And we increase the knowledge of all members, including new beekeepers. Each club meeting there is an open floor question and answer segment, and the opportunity before and after meetings to chat with experienced beekeepers. So basically, you can also learn by attending events and learning from other beekeepers and how they answer questions from the public, just spending time with them. The more you participate in the club, the more you will learn. Personally, I have learnt so much from the club and really appreciate the time that all of the wonderful members have taken time out of their lives to come along and show us, you know, how they work the apiary, how they record what happens on a day when they open the hives, and so on. And so it's great. So come along, join in. At the moment, unfortunately, our meetings are temporarily suspended whilst this COVID pandemic is going along. But once that is, things can return to the new normal, then everything will resume. You can find updates on our Hunter Valley Amateur Beekeepers Association website. So it's Hunter Valley Amateur Beekeepers Association.org.au. Thanks very much for joining us today, and I look forward to seeing you at one of our meetings soon. Thank you. Bye.
Hello and welcome everyone. My name is Ruth Luckner and I would like to welcome you to the following presentation, Toad at the Hive, which is brought to you by the Peri-Urban Environmental Biosecurity Network. I am the project officer for this network, which is led by Michelle Smith, leader of the digital delivery team at Tocal College, New South Wales Department of Primary Industries. So firstly, a little bit about the network. So who are we and what do we do? We are an online community of practice which connects experts in the areas of environmental biosecurity with people and communities in peri-urban areas of New South Wales. The network is engaging people from all walks of life who live, play and work in peri-urban areas to contribute to detecting and reporting new and environmental pests, weeds and diseases. So that means having more ears and eyes on the ground to report any suspect sightings. So we do this by sharing information on our website, through our social media channels, and through newsletters about environmental pests and how to report if you find anything unusual. You can also ask our experts if you have any environmental biosecurity questions. So today's presentation, Toad at the Hive, will be delivered by Mark Page, who is a Bee Biosecurity Officer in Surveillance with the New South Wales Department of Primary Industries. So thank you, Mark, and I'll hand over to you.
G'day, Mark Page, New South Wales DPI, Bee Biosecurity Officer Surveillance, and we're looking at a project today, Toad at the Hive. It's a citizen science project to look out for cane toads around your hives this coming summer. Some of the predators of our European honeybees could be water dragons. They'll gobble bees at the hive, especially if you're near a water source, a creek or a dam. Dragonflies will take bees on the wing, again near water sources mainly. Your spangled drongo, not a major impact. They'll generally take a bee here and there, but your rainbow bee eater, as the name suggests, will eat a lot of bees and have been known to impact on queen bee breeding operations. So, the one we're on the lookout for is the cane toad, Rhinella marina. And those two there having a hug, as you can see. And they love to snack on bees. So up in Queensland, where cane toads are established areas around there, they're running their hives up on stands to keep them away from the toads. The toads will sit at the hive, especially on a hot summer's evening, when the bees are hanging out, evaporating, and they'll gobble up bees. We certainly don't want that here in New South Wales, as well as the fact that it threats to native wildlife and even our pets. So they have no natural predators. It's capable of decimating all fauna species in newly invaded areas. There are a few things where the ricali or native water rat has worked out to eat certain parts of the toad, but remember, they're not in this area, so our ricali haven't worked that out yet. Their defence mechanism is to excrete poison from their bodies. Their preferred habitat, often in disturbed open vegetation next to waterways, areas like that. So backyard beekeepers and cane toad surveillance. So New South Wales is on the lookout for cane toads, and you as a beekeeper can assist with looking out for them at your own backyard hive or hives. The Peri-Urban Environmental Biosecurity Network, Department of Primary Industries, local land care services and recreational beekeepers associations will collaborate this summer to launch the first cane toad beehive observation night. And working with cane toad experts, we'll have a dedicated window for you to participate in this project, with further details to be clarified as the best time of summer and time of night. Register your interests. So Toad at the Hive observation night this summer, you can register online with the form. You see the rego address there, bit.ly/toad-rego. The Peri-Urban Environmental Biosecurity Network website, so bit.ly/peri-urban-envirobio. Keep an eye on your amateur beekeeping channels, newsletters and such, and also Facebook at the Peri-Urban Enviro. And remember to like us. Important not to kill a toad if you do think you have a suspect toad in your backyard. So there's some further information on catching suspect cane toads. The most important fact, as I said, not killing them immediately. It may be one of our native toads or frogs, so we need to identify that fact first. There's a cane toad biosecurity zone has been established to stop them invading New South Wales, and that's more up around the Clarence River and north. And further information on that zone and the cane toads, including an excellent 3D cane toad identification presentation, is available on the New South Wales DPI website. You can see the address there, www.dpi.nsw.gov.au/cane toad. And don't forget to join our network. Thank you.
We welcome Madeline Kratz, our friend and colleague, whose specialty is in honeybee nutrition. You're certain to learn something here. Thanks, Madeline.
Hi and welcome to the Beekeepers Field Day. I'm Madeline Kratz and I'm the Honeybee Development Officer with DPI New South Wales, and today I'm going to talk a little bit about honeybee nutrition and the sort of signs you can look for in terms of knowing whether your colony has the nutritional requirements that it needs, whether it's got enough stores and pollen and nectar sources coming in. And we have a look at some of the frames and some of the feeding options that you might want to think about if you do not have the nutrition that the bees need and if you do not have the option of moving your bees somewhere else. Okay, so first, what are the nutritional requirements of honeybees and why is it important? So it is important that honeybees have access to all the nutrients that they require, because otherwise, if honeybees feed off a poor diet, they become more susceptible to disease, they also become more vulnerable to pesticides, and their longevity will be affected. So bees will not live for as long, and overall it will affect the immunity of the colony. So what are the nutritional requirements of honeybees? So honeybees rely on honey or nectar as their source of carbohydrates, and specifically older foraging bees need the carbohydrates to be able to meet their energy demand for flight, for example. Honeybees also use carbohydrates as a source for energy to produce heat, and also it is used for wax production. So pollen, on the other hand, stored as bee bread inside the colony, provides bees with all other essential nutrients, and that includes protein, which can be broken down into its individual amino acids, fats or fatty acids, vitamins, and also minerals. The demand for pollen is specifically high when honeybees are rearing brood. So then the nurse bees need to consume a large amount of pollen to be able to feed developing larvae, but also all other colony members. Honeybees also have a requirement for water to meet their metabolic needs and to dilute the honey for consumption, and it is also being used to regulate the temperature inside the hive, especially when temperatures become high above 30 degrees Celsius. So honeybee nutrition is very important for the colony to be able to function. A sign that you can look for in terms of nutritional sources for a colony is to have a look at the entrance and whether you can see any honeybees coming back with pollen sources. So that's what you want to have a look at, and ideally also pay attention to the colors of pollen that the bees are bringing back. So if the bees are bringing back a range of colors, that's ideal, because then you know that they're going to different floral sources. And even if any of the pollens that they're bringing back are deficient, like a lot of our eucalypt species can be deficient in some essential amino acids. So they are amino acids that the bees can only obtain from their diet and not produce by themselves. So they really have to get them from the pollen. And some of our eucalypts are also low in fats. So if the bees can collect a range of different types of pollen, so for example also of other weeds that are flowering or other ground cover, then that gives them a good balanced diet. So you want to look for different colors. So at the moment it is spring where I am, and I can see the bees bringing in a bit of pollen. And what I've actually set up here is two nucleus colonies, so two small colonies, and what I wanted to see is how much pollen and nectar are they bringing in? Is it enough to get them going and grow for spring and build up their colonies, or do they still need a little bit more? What I've done here is I've set up two nucleus hives with different feeders, and the idea is that bees will go out and forage for what they need. So you always have a certain percentage of a colony that are foragers, and from that percentage a colony will allocate a certain amount of foragers to collect nectar, and the others will collect pollen. Some will be collecting a little bit of both, but they will adjust the number of foragers that will collect either one or the other depending on what the requirements are. So what we can look at now is actually have a look at their stores and see whether they have taken what I've actually been feeding them with. So this colony right here are fed with pollen supplement under the lid, and this colony over here has actually been fed with a front feeder with a 50% sugar water. And I'll talk a little bit more about what sort of concentrations you want to be using when, and what sort of feeding options you have in a minute. So first let's have a look at one of the colonies. So as we can see here, and this is a classic example of bees actually getting enough from the environment. So what I have done here is I've fed the bees with a commercially available supplementary feed, but they have actually not touched it. So when bees get enough from the environment, then they will not need any other supplement, and they will always prefer fresh resources over anything stored or any supplementary feed that we provide them with. Okay, so what I'm actually expecting to find in here, given that they have not touched a supplementary feed, is that they would have good amount of pollen stores. I do have to say that with this colony I specifically made it up so that they had foundation drawn frames, so frames with wax build up but no stores, because I wanted to see how they're going to respond to my feeding and what they're bringing in. So this was a little bit of an experiment, if you like, at a very small scale. So usually you would do this at a much larger scale if you were actually doing an experiment test. So what I'm looking for now is the amount of stores that they've brought in. So everything you can pretty much see here is what the bees have collected within the last couple of days. And what you can see here is that they've actually collected a variety of different pollen sources. So there's different colors here that you can see. And there's also a bit of nectar that they're bringing in. So really they are at the moment bringing in enough from the environment to feed off. So I'm just going to have a look also at the other frame. So usually the stores, food stores, you would find on the outside frames, and the brood would be in the middle. So here they've started to fill up the cells with a little bit of fresh nectar on that side. Over here there's still a lot of bees on here, so I might just quickly shake them off. And of course you have to check that the queen isn't there. So over here we also have these honey stores. They've already had that on that frame, so they just started bringing in a bit of nectar and a bit of pollen on that frame. Now the other things that you can look for in terms of knowing whether the colony has good nutrition is first the colony size. So now this is a small colony because I have actually split a larger colony. But you can have a look at how many bees are in the box, how many frames are they covering, is there a good cluster of bees? And then the other thing you can also look for is there a range of ages in the brood? So can you see eggs, can you see larvae and the different development stages and some capped brood? Just check if the queen is on here. So on this frame I can see capped brood, I can see larvae at all sorts of different stages, so that's a very good sign. And something else that you get used to looking at once you've checked a frame or had a closer look at the brood is the amount of royal jelly that the larva is surrounded with. So if there's a lot of jelly, if the larva is essentially swimming in jelly, if you like, then that is a good indication that there's a good source of nutrition coming in and the nurse bees are producing lots of jelly to feed the larvae. If that's not the case, then the larvae might look like there's only very little food source, so it almost looks a little bit dry in comparison. So these are the sorts of things that you can look for in a colony. So that first thing we looked at was what sort of pollen sources are the bees bringing in? Are they bringing in pollen sources? Then you can look at colony strength. How many frames are covered with bees? Look at the brood size and ages of brood, jelly production, and of course the food resources, so the pollen, amount of pollen and the amount of nectar. A colony, so full-size colony would only ever store about 1 kilogram of pollen as bee bread inside of a colony, whereas honey they store lots of. But depending on the demand, depending on the resources coming in the environment, the bees might be consuming that pollen store fairly quickly if there's nothing coming in, or that store can be there for quite some time if there's enough pollen coming in from the environment. So the other colony I've fed with sugar, and I know that they have taken up the sugar because I've attached the speeder to the front and I've actually fed them a few times. But what sugar feeding does, especially if you feed a more dilute sugar syrup, so if it is 1:1, so 50 parts sugar to 50 parts water by weight, for example, is you are mimicking more or less a nectar flow, so you're stimulating the bees. And with feeding, the key is to know what are you feeding, why are you feeding it, and when to feed, because depending on the time of the year, you might want to either just feed the bees to keep them alive, or you might want to feed them a thin sugar syrup like this one, which just attaches to the front of the hive if you're feeding small quantities, to actually stimulate the bees for pollen collection. And that you might want to do either in preparation for producing large colonies for crop pollination, or also in queen production, and if you want to rear drones, if you need lots of pollen to feed the colony. So to provide bees with a source of carbohydrate, you can feed a sugar syrup at different concentrations depending on the reason why you're feeding, as I just touched on. And you might even choose to feed dry sugar if you do not want to stimulate the bees. So that's the least stimulating out of the options we've talked about so far. The other thing to note is the type of sugar to feed. So the best sugar to use is standard table sugar, because that is sucrose. Other sugars, for example molasses, which is a byproduct of sugar production, is unsuitable to feed to bees, and even brown sugar and raw sugar also contain small amounts of molasses. If you are feeding large number of colonies, you might want to choose to open feed the colonies in a drum or a tub of some sort. The only thing to note there is to provide the bees with some sort of landing platform, like for example straw or cloth that they can land on, because otherwise they can very easily drown in sugar syrup. In terms of pollen feeding, so if the bees, or pollen supplements, if the bees are short on pollen and you want to provide a supplement, the thing to note here is that the best way to provide the supplement is feeding it as close to the brood as possible, because that way honeybees will take up the supplement and consume the supplement much more easily. If you choose to open feed pollen supplements, which is also possible, then you just want to make sure that the particle size of whatever you are feeding the bees with is very small, so that the bees can effectively pick it up. If you choose to feed back pollen to colonies, then that can also be done, but what's really important there is that the pollen has to be irradiated, because otherwise it can transmit disease through the pollen. And if you would like any more information on supplementary feeding or the nutritional requirements of honeybees, there is a book that I would like to recommend to you called Fed Bees, Skinny Bees, written by Doug Somerville, and that can also be downloaded as a PDF online. So that is a very practical guide on honeybee nutrition that I would highly recommend. If you want to know anything more about the quality and quantity of nectar and pollen sources, there's another excellent book written by Doug Somerville called Honey and Pollen Flora of Southeastern Australia. And with that, I would like to say thank you for your attention, and I hope that you enjoy the rest of your day.
Tocal College has published close to 100 books on all aspects of agriculture and land management. All of our publications are up-to-date, best practice, accurate and reliable references relevant to modern ag. They are easy to read with useful illustrations and photographs for practical understanding of the subject matter. Printed and electronic, Tocal's publications in beekeeping titles include Honey and Pollen Flora of Southeastern Australia, Bee Ag Skills, and our ag guidebooks, Healthy Bees, Queen Bee Breeding, Honey Harvesting and Extracting, Pollination using honeybees, and Australian Native Bees, available now from our online bookstore. We are offering a 15% discount on all our bee publications today and tomorrow. Simply use the code TOCAL15 at the checkout to receive your discount. Happy reading!